Welcome to your 8.2 No Guide about recursive rules for sequences. We had just gotten done with section 8.1, which talks all about explicit rules of sequences, but now we're going to talk about recursive rules. And it's a very powerful section, and I actually find it kind of fun, but you can let me know how you feel about that when we're done. The objective here is to list the first few terms of a sequence given the recursive rule. So first, just kind of getting used to how recursion works, and then to write recursive rules for sequences. And I've got to tell you that we do very little of this at the high school level, recursion in general, unless you're doing a lot of programming stuff with loops and so on. But in proofs at the university, we use recursives all the time. And it's very important to get to know just the terminology and how to do it, to be honest. Okay, so let's start with just what a recursive is. The first thing is it gives always the first term or terms. Usually it's the first one, but you'll see in our note guide sometimes we do give you the first two terms. It makes for a more interesting kind of sequence. Number two, and then from there it gives an equation to find the a sub n using the previous terms. So that's the big difference between recursion or recursive versus explicit. Explicit is a rule that you can put in whatever term number, let's say again 128. You can put 128 in for n to find the value at the 128th term. Now recursive is that you are given a rule that you're always using the previous term or terms to find the next one. So it's always using the previous to get to the next one and so on. And if you're not really seeing the difference between that, you're going to see it here very, very quickly. So the notation, first term, as you probably figured out by now, we'll call that a sub 1, second term is a sub 2, and the nth term is a sub n. So no different than what we had done in the last note guide. Here's where it gets a little different. Because we're always talking about doing something to the previous term to get to the next term, we use this a lot, a sub n minus 1. A sub n minus 1 right there. That gets us to the previous term. If I want to do two terms prior to the term I'm talking about, we'd go a n minus 2. So it's all about positioning, really. So we know a sub 1 is the first position, a sub 2 is the second position, a sub n is anywhere along the sequence. But if you see a sub n minus 1, that's talking about the term before the one you're currently talking about. So if you're referring to a sub 1, you're talking about a sub 0. If you're talking about a sub 2, you're talking about a sub 1, and so on. And again, we'll do some practices here so you again are understanding what I'm saying in general. Recursive rules are often used in programming. By the way, it should have had two M's in there. That's a misspelling, and that drives me crazy. Recursive rules are often used in programming, especially in the app games that you love so much with loops in them. Computer programming cannot exist without recursive rules. So here we go. Let me kind of show you how it is. And like I said, I kind of dig this, but some people this kind of blows their minds, so just kind of bear with me. So if I'm a little redundant on this note guide, keep in mind that I am teaching to the masses, and some people pick it up very, very quickly, and others I really do have to spell it out very slowly for them. So if you see it quickly, just kind of bear with me. So what we're doing here is it says give the first 5 terms of the sequence. So I know I'm talking about 1, 2, 3, 4, 5. That's my answer, really. I eventually need to have those spaces filled out. I'm given the first one, so I might as well throw it right in there. Now the second one is not as obvious, and I really, again, I could show you very quick tricks to answer the question, but I need to make sure that especially if you're going to university mathematics level courses, that you understand how to navigate this. What this means is, hey, we have the first term. Now let's do the second term. I need to know the value of the second term, so a sub 2. So that means that we are taking and we want to know the second term, minus 1. Notice that that's the notation, minus 6 out back. So we have that the second term is going to equal whatever the first term was, a sub 2 minus 1 is a sub 1, minus 6. So we just are going to take, to find that second term, we're just taking that first term, which is 3, and subtracting 6 from it, which is negative 3. So that is a very, very linear algebraic way of showing how recursion works. Now, if you thought to yourself, well, I know that n minus 1 is, a sub n minus 1 is the previous term, and my first term was 3, wouldn't we just go 3 minus 6? Yeah, that's exactly what you're doing. But again, they do get a little bit more complicated, so let me just kind of go through this again. If push comes to shove, at least I'm giving you an algebraic way of finding the values. So to find the third term, we're essentially going to look at the second term, or the 3 minus 1, a sub 3 minus 1, minus 6, and that's a sub 3 equals a sub 2 minus 6. So that just means we're taking the a sub 2 value, which we just found, which is negative 3, minus 6, and that's going to give me negative 9. And you can keep doing it algebraically, don't get me wrong, but at this point I'm going to say, well, we know we subtracted 6 to get negative 3, subtracted 6 to get negative 9. If we subtract 6, we'll get negative 15, and lastly, negative 21. So I find that I have more students from all different classes coming in getting help for this specific concept. So that is the one thing I just wanted to show, more of a concrete way of finding these values than just saying subtract 6, subtract 6, and so on. Okay, so let's do letter B here. So I know that the end thing is going to be 1, 2, 3, 4, 5 terms. I know that, now get this, we're not starting at the first term, we're starting at 0. A sub 0 equals 1. So this is actually like my 0 term. Then I'm going to my first term, second term, and so on. And that kind of, again, we usually, most of the time we start with a sub 1, but we want to make sure that you guys can navigate any water or experience, I guess, that you're going to get thrown. So I have my 0 term, so now I'm going to do my first term, a sub 1, and find that value. So I have negative 5 times a sub 1, because we're doing our first term, minus 1. And of course, kind of like what we just I was showing you, negative 5 times a to the 0. We know a to the 0 was 1 from the previous, from this up here. So we're going 1 times negative 5, which is negative 5. And again, you can keep doing this algebraically. A sub 2 equals negative 5 times a sub 2 minus 1 is 1. Now my first term is right over here, which is going to give me negative 5 times negative 5, which is 25. So what are we doing each time? We are multiplying by negative 5. So interestingly enough, letter A, obviously we're writing it as a recursive sequence or a rule, but hopefully you also recognize that is an arithmetic sequence that then you could clearly write an explicit rule for as well. Letter B, it's a geometric, because the difference is negative 5. And so now I would hope, using the previous examples from the last note guide, we could then, of course, make a rule for that. Ooh, you know what? Let's see, negative 125 times 5 is giving me, oops, I shouldn't have said that, negative, is 625. I don't know why. All of a sudden my brain was not working there. Okay, so that is how you do those examples right there on the first 5 sequence, or excuse me, the first 5 terms of the sequence. Now, this one is kind of interesting because this is where I'm saying that showing that very algebraic way of finding the values seems to help some students. So letter C, notice again, the end result is going to be 1, 2, 3, 4, 5. And actually, I should have done this right because here is the final answer. So letter C, our first 5 terms of the sequence. Well, ironically, again, we're starting at a sub 0, so the 0th term is going to give me 1. The first term, well, really it's the second term, right? Now you can see why we start with a sub 1 instead of a sub 0. But so we start with 1, then we get the value of 2, and then what we need to know is what is the third term, technically it's the second term, and so on to fill in the sequence. So notice what we're doing here in this recursion rule is that we're taking the previous term and multiplying it by the term in front of that. That is what this rule is saying. Now, if you're going, I don't see what she's talking about, let me show you. So I obviously, this is the 0 term, this is the first term, now we're doing the second term. I'm going to put anywhere there's an n, a 2. I mean, if you want to keep it like that, right? Just because we're talking about that second term. And now let me simplify this. So a sub 1 times a sub 0. Well, we know our a sub 1, or our first term, is 2, because it's right there. It's our 2 is that value. And our 0 term is 1. So the answer here is 2. So we really are multiplying these two together to get this one. So 1 times 2 is 2. Now, let me erase this so I don't get confused or confuse you all. Let's do the third one just to kind of make sure that you're kind of seeing. Again, this is the third term and the fourth term to give us 5 terms in the sequence. So I'm going to go a sub 3 equals a sub 2 times a sub 1. If you do it algebraically, that's exactly what you get. And all that's saying is that we're going to go 2 times 2. The value at a sub 2 is 2, and the value at a sub 1 is 2. 1. Yeah, 2. Which equals 4. Now again, you can do one more algebraic thing if you want. A sub 4 equals a sub 3 times a sub 2, and that gives me 4 times 2, which gives me 8. And at this point, some of you are going, oh my gosh, just move it along, Miss Bakken. Anyway, so notice 1 times 2 is 2, which gives me this one. 2 times 2 is 4, which gives me this one. 2 times 4 is 8, which gives me this one. Recursion at its most beautiful. The only thing you would list is not these term values. That was just to help explain it. But it's that 1, comma, 2, comma, 2, comma, 4, comma, 8. That is what you're showing. Okay, so that is kind of navigating, as the objective 1 says. List the first 5 few terms of the sequence given a recursion rule. There you go. That's exactly what you do. Now, example 2 is a little bit more interesting, in my opinion, although you can't do these without understanding the first part anyway. It says write a recursive rule for the sequence, kind of like before we found the explicit rule. This is the recursive rule for the sequence. So we're writing things that look like our example 1. Notice the asterisk means that there's more than one term. There should have been one term used in the rule. And I will say that there should not have been an asterisk here as well. Notice that there's all sorts of edits on this note guide, huh? Okay, so we have 500, no, we've seen this before. There's 512, 128, 32, and 8. It's like I need new material, don't I? So the reason I say we've seen it before is because our first note guide had it twice on there. And if you don't remember, what we did do was we knew that you're dividing each of the previous terms by 4. So let me just show you how fast recursion is, or writing a recursive rule. First of all, you need to know your first term. And you could start with a sub 0 if you really, really want. I like starting with a sub 1 because it's easier to talk about, especially in a video. So I know my first term is 512. So that's the first thing you always need to do. You need to write just the initial value. From there, now you have to say, okay, what do I do with that value to get to the next term value? So a sub n equals. So I know that I divide 512, or multiply 512 by 1/4. So if I go 1/4 times the previous term, which would be a sub n minus 1, we are in the money. So what we're saying is that if you take a sub 1 and divide it by 4, you get 512. How do we get to that first term? Well, we subtract 1 from that term number to get it back to that first term. So, by the way, with recursion, because there's no such thing as like necessarily the difference or the ratio. I mean, there is, but there's no rule that says you can't say it like this. A sub n minus 1. Ooh, that's an n minus 1. If you can't read it, I totally understand. N minus 1 divided by 4. You can completely say it that way as well. So this whole thing is the answer. And again, if you were going to write it like this, you would have had to first list the a sub 1 is equal to 512 up here. So this would be the other way to do it, although I'm not going to do that because, well, because it's getting messy. Okay, So letter A, you have to first write the initial value, the starting value, and then from there you are figuring out what you're doing to that value to get to the next one, and the way you get to that first or start or reference that first one is by going a sub n minus 1. Okay, so let me kind of show you a little bit more. So here, if you want to start looking at it, we have 2, 4, 16, 256. What's happening here? Well, I see 2. To get to 4 from that, instantly people are going to say, well, multiply by 2. Yeah, but if you go 4 times 2, that's not going to give you 16. So I'm looking at it and I'm thinking squares. So 2 squared, oops, I have to switch it back over. Let me actually make it a little bit bigger. 2 squared gives me that 4. 4 squared gives me 16. 16 squared gives me 256. So again, you're always thinking about the first term and what you have to do to that to get to, so what do you have to do to this to get to this? What do you have to do to 4 to get to 16, and so on. So the first thing you always do is start with the very beginning term, and then you're going to go, okay, I'm going to take that first term, which is a sub n minus 1, and square it. So again, so if you put, just to give you an example, just to make sure you're seeing the picture, so if I go a sub 2 equals a sub 2 minus 1 squared, that's saying a sub 1, the very first term squared, which is exactly what we want, right? 2 squared, which would give me 4. Then you go to the next one. And so always to get to the previous term, you're doing this. To get to the previous 2 terms, you'd go n minus 2, which is going to play a role here very, very quickly. Now, what is the thing that you're actually, what is the true answer? Keep in mind it is the initial amount first, that a sub 1 equals 2, listing that, because you need to start somewhere. And then from there, you're writing the recursive secondary part of the rule. Okay, so the Fibonacci sequence. We love the Fibonacci sequence. If you've never seen it before, it's really the first 2 terms here add up to this third term. These 2 add up to this one. These 2 add up to this one. These 2 add up to this one. So the previous 2 terms add up to the third term is really what's happening there. And it's super, super cool. Now, so this is, notice it's starred. The reason being is that you're not just using one term. You have to list, how did I write it up here? I said means more than one. Remember, this was supposed to say 1 right here. 1 term is used in the rule. So what I mean by that is that you're going to need, and I'm going to make it big again because it's a little bit easier for me to write. I'm going to say a sub 1 is equal to 1. A sub 2 is equal to 1. So we know this is the first term, second term, third term, fourth term, fifth term, sixth term. So I have defined in my recursive rule the first term and the second term. And the reason being now is that I can take any term, so a sub n equals, and take the previous term, a sub n minus 1. Oh gosh, my handwriting's getting worse and worse, isn't it? N minus 1. And add that to the previous term from that, a sub n minus 2. So this is the previous term. This is 2 terms before the one that you're referring to. So if we're focusing on this one right here, it's saying a sub n minus 1 is this one, and a sub n minus 2 is this one, 2 terms before the one that we're focusing on. So it's taking 1 plus 1 to give us the circled value right there. Now let's just kind of keep that and see how that works continually. So if we go to, let's say, this 5th term right here, ooh, geez, that's not what I meant to do, was it? If we're you know what I'm going to do? I'm going to focus on this one right here. So I know that's the 6th term. So what this sequence is saying is, hey, if you go a sub 6 equals a sub 5 plus a sub 4, because I'm using this rule right here, and that means a sub 6. Well, we know the 5th one is 5 right here, and we know the value of a sub 4, or the 4th term, is 3. And that means the 6th term in the sequence is going to be the value of 8, which it is. So again, recursion is always using previous terms to compute the current term that you're interested in. So I'll actually leave that on here so that, but it's really, this is just me just trying to show and continue to explain how recursion works, because while I look at it and it makes absolute sense, I know the first time is very, very disconcerting, because it's like you think you have it and you have it down, and then all of a sudden you kind of don't have it down. So letter D, remember I had this as an asterisk, but it actually is not one, because if you look at this, if this is your first term, second term, third term, and fourth term, and so on, and of course you always in recursion start with defining the first term. What do you do to that term to get to the next one? Well, you multiply by 2. And then what do you do to the second term to get to the third one? You multiply by 2. What do you do to the third term to get to the fourth one? You multiply by 2. So this is actually very similar to the geometric, but again, this is recursive. So what we're doing is we're saying, hey, I'm going to take the term number, which is n, we'll just say n, times the a sub n minus 1. And let me just kind of show you how that works. And actually, now that I think I was, sometimes when I'm doing the videos, I'm thinking about one thing and then realizing, oh, I just said something completely wrong. So let me try this again. 7 times 2 we know is 14. If I go 14 times 2, you're not going to get 42. It's not a times 2. It's not a geometric. Sorry about that. 7 times 2 is 14, but 14 times what gives you 42? That's going to be the 3, the term number. So really what's happening is that 7 times 2 gives me 14. 14 times 3 gives me 42. That's the better pattern, right? 42 times 4 gives me the 168. So really what we're dealing with is the previous number, previous term, so that a sub n minus 1 times the actual term number. So this is kind of an interesting one because it isn't as straightforward as perhaps the other ones were. So let's just kind of, again, now this is the answer, this right here, but you're going to be like, oof, I don't know if I would have saw that, Ms. Bakken. But let me just show you, like, let's talk about that fifth term. So a sub 5 equals. So what this means is we're taking the fifth term value, or the fifth term's actual, like, number 5. So it's the fifth term, so we're putting 5 right here, times a sub n minus 1, which is the value right before the fifth term, which is 168. And when you go 5 times 168, that is going to give me a number that I didn't type in right. So, and just as a verification, I'm getting 840. So it checks out into what we're seeing there. So you're just taking the previous value and multiplying it by the term number, which is super cool example there. As long as I say it right, folks? Okay, so letter E. Letter E, let's kind of see if we can, see what's happening with this one. Notice that both E and F are starred. So what I might do with these really quickly is know that we're dealing with a sub 1 equals 14, a sub 2 is equal to 20. Can you see what you do to those two to get to the third term? So what are you doing with these to get to this? And looking at it, you can pretty much see that you're going to take 20 minus 14 to get 6. Now let's just double check that that pattern's actually working though, right? Because if it's working, then it means 6 minus 20 should give me negative 14. Does that work? Yes. Okay. So I'm being a little more cautious because of how flippant I was in that letter D, and then I was wrong. So a sub 1 is 14, a sub 2 is 20. So a sub n is going to mean that we need to get to, and this is kind of where we need to, I'm going to erase this right here. Then I'm going to just, as a reminder, say this is first term, second term, third term, fourth term, fifth term. So to get to that third term, and sometimes that helps, so to get to this third term, I sometimes write it right below it. I need to get to my second term. I need to get to my second term and then subtract my first term from it. So if that's the case, it's going to be a sub n minus 1. So that term right there would get me to my previous term minus my a sub n minus 2 to go 2 steps back. That looks like some sort of weird, oops. And that, my fine young ladies, gents, is it. Because now you know what your a sub 2 is 20, you know a sub 1 is 14, and that gives you 6. And that pattern will continue. So what is the answer here? It's going to be this rule with, of course, the initial amounts defined. Okay, and this again was just down here is just my help to make sure you understand what's happening there. And what I did there, I do all the time. I scribbled the third one to try to figure out what it is pattern-wise and kind of making sure that it's following what it needs to follow. So again, this is a first and second term or multiple terms definition. So a sub 1 I'm defining as -5, a sub 2 I'm defining as 2. What do you do to those two to get to this value? I would hope you say, Spock, and you're just multiplying them together, and that's exactly the case, but let's make sure that pattern works. If you multiply these two, do you get this value? If you multiply these two, do you get this value? And the answer is yes. So now we need to figure out what the rule is, or how to write the rule. I mean, we know what the rule is, we just need to be able to write it now. So I know I'm going to start with a sub n, and if it helps, 1, 2, 3, 4, 5, if it helps to put right below this a sub 3 equals, I obviously know that I want to multiply a sub 2 times a sub 1, because my a sub 2 value is 2, my a sub 1 value is -5, and that would give me the -10 I want. So I have a sub n equals a sub n minus 1, that gives me the previous term, the term 2, times a sub n minus 2. Now what if someone says a sub n minus 2 times a sub n minus 1? That is absolutely fine because we know that is something we can do. Now the top one, letter E, we obviously can't change the order of that, but letter F, obviously with multiplication, we have commutative property that works, so we can definitely change the order without affecting the value. So what is the actual final answer here? It is this right here. So practice makes perfect with these as well. As explicit, I find that we tend to keep the problems a little bit more on the straightforward side, just especially as you're learning it. But again, a lot of what's going into recursive this section is, first of all, being able to handle this idea of a sub n minus 1 and a sub n minus 2 and knowing what that means. It's all just about positioning and getting your feet wet with that kind of notation. So if you have any questions, of course, we'll go and answer those in class. But otherwise, thank you for tuning in.